Hello guys, in this clip we are going to talk about different types of influence nodes inside Bifröst Aero. Influence nodes can modify the motion of your simulation. They include effects like wind and turbulence, but the question is, how can you add them to your Bifröst graph, and what's the order of applying them, and how can you change the behavior of your simulation? All these small questions can be answered in this video, so let's get started. Now, before we get into this simulation, let's talk about what we have here. We have a couple of, if I just unreference the scene, we have a couple of burnt toasts as an excuse to produce smoke that's coming out of this toaster. And of course, a simple scene that comes with it, a backdrop, and I will make that scene available to you guys via my Patreon. The idea is not to match the look of the smoke, but rather to use the scene to explore the behavior of the influence nodes when you create your smoke. So I don't need to observe any reference simply because we're not trying to match anything. With that said, I'm just going to reference everything else. I'm not going to select anything by accident. If I go to perspective, I have my emitter. So if I isolate just the emitter, it's nothing more than a simple patch that I carefully placed, and I will be using that as an excuse to emit smoke. Let's start. I need to make sure that my plugin for Bifröst Aero has been already loaded. I have that, and I have the shelf that comes with it. With that, I'm going to go to Bifröst Graph to create my graph. Now, I'm not going to spend too much time on this because I already have a video introduction to Bifröst, and I go through how to start with your Bifröst graph to create smoke, what are the key components and the compounds, and all the key attributes. So I put the link in the description in case if you haven't watched that. I also add to it if you're interested in using more than just the density, if you would like to bring temperature and create fire, I have another video on how to create fire out of Bifröst using the same structure, almost the same structure. So a lot goes into those videos, so I'm not going to basically repeat myself. I'm going to create a graph, simple as that. You get input and output. For input, I would like to use this emitter right here. So middle mouse, bring the emitter in, and that would be my input. I'm just going to leave the other input over there because I don't need it. And the output, eventually my simulate node will get connected to this output. Now, I'm just going to produce my source air. And this source air has got some attributes, and it basically converts your geometry into an air. So we want that to be enabled. Start frame 1. We don't want to specify end frame. I will set the resolution mode to absolute. Again, I'm not going to spend too much time covering this because I've already talked about this in other videos. Geosize detail, I lowered the resolution just a tad, probably 0.03 would be a good number. I leave everything else as is. I don't want to have any adaptivity. I go to air properties. Again, fine-tuning my detail size fluid, lowering the resolution right off the bat because I just want to see what I'm working with. Fog density of 2.5 gives me a very, very thick smoke, even a thicker smoke when you render it, which is probably very, very unrealistic. But again, that's fine. I want to see what I'm working with in the viewport, so I'm just going to use a value of 2. Just so you know, if you are rendering this, you have to reduce it to something like 0.3 or 0.4 so it looks realistic. But in the viewport, if you work with 0.3, you're basically not going to see anything. So fog density mode, I'm just going to set that to max, and temperature is way too high. 200 will get the job done. We're not really working with temperature that much. So initial speed, I need a little bit of speed to have the simulation going. With speed mode, I leave it at rate and inherent velocity just a tad, and trail smoothness, I don't want to basically smooth my smoke too much, so I'm going to reduce that to 1. Now with that done, I need the second most important component. I'm going to press tab and type in simulate, and then bring my simulation node. Source air goes to source, and then from here Aero volume goes to here. Now, just for your information, this simulate Aero compound kind of holds the core solver that simulates the air, and there's not much attribute in there apart from settings, so we need to have that Aero solver settings as well. Solver settings, bring the settings for my solver, and of course solver settings in goes to settings. I'm not going to really change anything at this stage. I just want to keep it as default so you guys can follow as well. Well, one thing we need to make sure that we do, because right now if I play I don't get anything, I need to make sure that I have the input connected to my source air. As you can see, source air gets connected in here to here. Now if I just minimize and play, you can see I'm getting the air coming out. And now we're getting close to why we made this video, because right now this looks like a mushroom puff that goes up, and there is no way to direct the look or to sculpt the look, for lack of better word. Yes, it looks all good, but at the same time it actually looks very boring. So let's stop the timeline and rewind, and let's see how we can modify the motion of our simulation so it looks more interesting. I'm going to bring my Bifröst graph back, and by the way, at any point of time you can just press L and organize your graph. We don't need this little guy, it can come over here. Let's move to the next chapter and explore all the influence nodes that Bifröst made available to us. Now, the first influence node I'm going to explore is probably the most important one, and without a doubt one of my favorites: Turbulence Influence. Now, Turbulence Influence applies a curl noise to your simulation, and it's useful for effects like air turbulence, where you would like to simulate airflow, which results in more natural smoke simulation. So using it, however subtle, is a no-brainer. So let's see how we can get that done. To use or to apply the influence node, you have two ways of doing it. You can just press tab, go to simulation, and go to influence and find turbulence in here, or you can just tab and type in turbulence, and the first on the list is Turbulence Influence. We are going to address a very important point here: where to connect the influence node. All the influence nodes are going to simulate Aero directly under influences. Now let's have a look at what the smoke looked like before we apply influence. That's the look. Now let's see what we have as our attributes, and then we are going to quickly have a look at after. So every time you apply an influence, you also have an input in your influence, and that gives you more options to deal with. You can mask your influence, you can modulate your influence, add randomness to it. exclude or include a region of your influence. We are not going to talk about those at the moment. I will create a how-to video to add layers to what you already know, but we're just going to focus on the main building blocks at the moment. So while you have this influence part here, let's focus on the properties. Obviously, if you would like to temporarily mute your influence or deactivate it, you're just going to tick off this enable checkbox. Then you have turbulence property, and that is simply the magnitude of the effect. So you intensify the turbulence by increasing this attribute. For this particular scene, and considering the scene size, I believe that something like 2.5 will get the job done. And then you have the frequency, which works very similar to the frequency of fluid simulations in Maya, let's say. I'm going to put 2.5 for the frequency, which controls the size of the noise. In case if you're not familiar with frequency, higher values will result in smaller vortices. And if I bring this down to something like 0.5, you will get a much wider length. Higher values will give you smaller length. Change rate controls how fast the curl noise evolves over time, which is extremely helpful. Let's say you've got a cigarette smoke where the smoke rises almost straight and then curves. Then for that, you need to lower this change rate. But for something like toaster, you probably are going to see some turbulence right off the bat. So I probably am going to keep it at 1, maybe 0.9, but I'm not going to lower it too much. And then you have drag, and you will see that drag in pretty much all the influence nodes that we are going to use, which is simply going to dampen the simulation. So if you feel like your simulation moves fast, drag will slow the simulation. For now, I'm just going to leave it as default. Now with this, if I minimize, rewind, and do a quick play blast, you will notice a massive difference. Look at that. Left hand side is before and right hand side is after. And you can see how much curliness we added to the noise and how exciting this smoke looks with just one influence nodes. And that's the power of the influence nodes. Now that's one look you can get, which may not necessarily be the look that you want. So let's explore the next influence node. Now the next influence that we are going to explore is called Dissipation Influence. That works by itself or in conjunction with other influence nodes such as turbulence that we've already created. So I'm not going to disconnect that. I'm just going to leave it as is. I'm going to press tab and just type in Dissipation Influence. Dissipation Influence comes up. If I go to parameters window, again, we have another port that you can assign masking or modulating type of nodes to it, but relatively a simple structure that we're dealing with Dissipation Influence. Now, the main functionality of this node is to create decay, basically how soon the smoke dissipates. If the smoke rises to infinity, that can create a lot of problems, especially if you're not working on a high-end computer. You may run out of RAM and eventually Maya is going to crash. Not to mention that sometimes this look is dictated by your reference. So you have, let's say, Steam, and in Steam, the Aero simulation dissipates fairly quickly as opposed to thick smoke. So sometimes the reference you have actually asks for quick dissipation. We have, again, activation button. enable or disable, we have the rate, and that rate shows or determines how fast the smoke decays. In my particular case, I really don't want this to decay to a full value of 1. I'm just going to reduce it to something like 0.65 or 0.7, let's say. Let's give it a try and see how it goes. Actually, let's start with 0.65 and see what we get. Now, the property that you are applying this to is also important. Remember, every time you work with source air, you're mainly targeting density. And that's what you see. Sometimes you want to target temperature and you change that to temperature, to voxel temperature. But if you are targeting the density, just basically targeting your smoke, it's always voxel fog density. So with that in mind, I'm just going to go to out influence to influence port, connect that again. And with a combination of turbulence influence and dissipation influence, let's play blast the scene and see what we are getting. Now, here's the result. You can see how fast the smoke dissipates and creates a completely different look. So not only these influence nodes can do wonders by themselves, you can always combine them and mix and match them to get closer to your own reference. And again, that's the power of visual programming or procedural way of applying simulation, because it allows you to basically to not only control those key attributes through parameter window, but also procedurally connect and disconnect nodes and compounds and get a better look. Next one on the list is buoyancy. Now I'm going to disconnect dissipation and move it to the side. We don't need it anymore. We are going to replace dissipation with buoyancy, which does the opposite. And that's why I'm covering these two right after each other. Dissipation kills the smoke. Buoyancy helps the smoke to rise up and accelerate the movements of either temperature or fog density. So I'm just going to press tab, type in buoyancy, and bring buoyancy influence. Buoyancy only works with the simulate Aero solver. So if you're planning on using buoyancy with particles or NPM, at least for this particular version, you can't. So hopefully that will be something that will get improved on in future versions, but for now, in Maya 2022.2, this is not applicable. So it's very simple. We go from out to in, port in the influence. I leave turbulence as is, so won't be changing anything here. I'm going to go to buoyancy, looking at the parameters window. We have influence, again, just like any other influence node. We have port that comes with the influence node. We have the activation button, makes it we can enable or disable the node, and of course the buoyancy itself. Now the buoyancy is set to y-axis 9.8, but you can increase it to whatever value you want. Let's say I'm going to increase it to 25 just to intensify the acceleration, and let's do a quick play blast. Now you can see how much faster we're having that rise of smoke, and that's pretty much what buoyancy does. So if the reference asks for it, then you can actually speed up your smoke or accelerate the movement of your smoke by increasing the buoyancy, which again will have an impact on both density and temperature, which is actually quite useful. Let's move on to the next one. Now for the next influence node, I'm just going to keep turbulence and buoyancy, which kind of works well for me. Probably I'm going to go and reduce the waviness of my turbulence, so we get much bigger waves. So setting it to probably 2 and make it more intense. So turbulence parameter, I set it to 3. And for buoyancy, maybe a value of 30 will be good. The next one that I'm going to apply, it's called wind influence. Without even me saying this, you know what wind influence does. It simply applies wind to your scene, which is extremely useful actually. It comes with the port for getting more auxiliary nodes, and for the input, it comes with few attributes. Wind speed is how fast the wind moves. I noticed that a value of 5 is way too high. I'm just going to reduce it to something like 1.3. Wind direction, we have X, Y, and Z. If I look at my scene, I want the wind to go in the positive X, so I'm not going to change the default value. Probably going to add a little bit of Y to it, so it pushes up as well. And drag, as usual, what this does, it actually dampens the simulation. Now I can go from out to import of my simulate Aero solver. One thing that you can do, again, I'm going to create another how-to video to explain that, but you can bring in useful influence nodes such as modulate, and modulate the movement on your wind. You give it in and out, you target your property, which can be voxel fog density or voxel temperature, and in that case you use gradient. But I want you to experiment with it, that it's not just one influence that changes the behavior of your smoke. You can even add auxiliary influence node like this and get more exciting look. Leave that for another tutorial, but for now let's focus on this. All right, that's what we have. Let's go ahead with the look. I'm just going to minimize and do a quick play blast. Now you can clearly see that the smoke has been pushed towards positive X. Great example if you have, let's say, an open window right next to the source of smoke and you want to give this little bit of directionality. So I found this very useful. Of course, you need to make sure that your reference is also asking for it, but keep that in mind next time you create smoke. Let's move on to the next one. All right, I'm going to unplug the wind and move it to the side, and let's replace it with another useful influence node called drag. And although we have had a drag attribute on influence nodes such as turbulence right here, drag by itself can be an influence node, and it can be a very useful one. Now, this influence node can be used to simulate effects of air drag. By itself, drag influence dampens the simulation or the velocity of the simulation. But if you use this as a node by itself, you can actually create all sorts of useful and crazy looks, such as slow motion smoke. So there's not much in there. You have enable, disable, and of course the drag rate. So it can be useful if you use drag in conjunction with other nodes, such as wind or gravity. But for now, we're going to go and have output to influence port of our simulate Aero. And let's see how this slows down our simulation with the default rate of 5. Now look at that, isn't that cool? So it actually slows down the simulation and it looks like it's flowing like water. So another look, probably not the best look for this particular example, but sometimes you have a graveyard and you would like the smoke to kind of creep in, something like fog, and you need that gradual, subtle motion while you're maintaining all those swirls and viscous smoke. In that particular look, you definitely want to mix in drag as well to kind of tone down the movement of your smoke. Very useful, cannot be applied on every single simulation, but now you know, I'm pretty sure when the time comes, you know where to use this influence. Let's move on to the next one. All right, next one we're going to talk about is called Radial Influence, which works really well if you wish to push your smoke in all directions or vacuum your smoke into a particular area. So I unplugged the turbulence node and other nodes to just have this node by itself so you can kind of clearly see what this one does. What drop-off does in the parameters window, it works very similar to attenuation in fluids, where if it's set to 0, it will have an impact on the entire scene. By increasing the drop-off rate, you're actually creating a fall-off. So object further from the source air will get affected less. And obviously this will control that. I will definitely want to set fall off to 0. Center specifies the location. My object is sitting right at the center at the moment. So if I go in here into perspective, if your object is sitting at the center, then this value center to 0, 0, 0 works. This is basically the origin position of the radial acceleration. I'm not going to change that. Magnitude is probably the key attribute in here. I can increase that to something like 4, just to exaggerate a little bit, and push away the smoke in all directions. It kind of reminds me of volume emitter in particles, where you have away from axis attribute to push away the particles in all directions. Does the exact same thing if you are familiar with fluid simulation in Maya. Now, the important thing that you need to know about this attribute, you can go actually minus if you want, and minus values do the opposite, meaning that if you put in negative values, it actually push towards the center, and that can create all sorts of interesting results. So keep that in mind. I'm just gonna set that to actually 4, not 0.4. And of course, drag is going to dampen the result. I'm not going to use any dampening. With that setting by itself, I'm just going to plug that to my influence port in my simulate error solver. And let's do a quick play blast and see what type of result we are getting. Now you can see how this influence pushes the smoke in an omni fashion. Probably not the best look for this example, but again, the whole idea behind this tutorial is to explain what influence does what, so when the time is right, you guys can use it. Hope you find this one useful. Let's move to the next one. Next one on the list is vorticity. So if I type in vorticity, here's the node. I get that question a lot because students say that vorticity looks like turbulence, and they're actually correct. Vorticity is another type of influence where instead of having a viscous, smooth looking smoke, you get small scale vortices. So if you think about a cigarette and how cigarette smoke moves, there's a sense of viscosity in that sort of movement. Whereas compare that to a smoke from exhausts, or where you have excessive amount of smoke coming from your vehicle that could indicate, let's say, head gasket failure. Now, there's nothing swirly and viscous about that smoke. It's almost powdery. And that's a really good example of how vorticity works. There is not much in vorticity. If I go ahead and connect that to the influences port, you get the intensity of the vorticity, and you get how small or how big is the scale of your vortices. And you have an option between 0 to 1. Smaller scale to slightly bigger scale vorticity. And you get an interesting result right off the bat, something that you can use. Again, a perfect example for me would be chimney, smoke coming from chimney or smoke coming from exhaust of a vehicle. That can be a perfect example for vorticity. Without changing anything, actually, let's just minimize and do a quick play blast. And you can see instantly the difference between vorticity and turbulence, and how you don't get that amount of swirl and dancing smoke with a little bit of viscosity. You rather get a very fast moving, small scale vortices instead. Now we have one more influence to cover. Obviously there's a lot to talk about, but at this stage I think that length would be appropriate for one video. Let's move to the final influence. Now, finally, let's get to the 9th and last influence node that we are going to cover in this video. Now, this one is called Attract Repulse Influence. And as the name suggests, it's a super cool influence that can attract to an object or to another influence and repulse. So very, very useful when you try to guide your smoke. This can be extremely useful. So you can put an object to follow the curve and get the smoke to follow the object via this influence. So let's get that one connected really quickly. You can see if I click on this node, you can feed that into the influence attribute, or you can plug in a geometry, move the geometry and get the smoke to follow the geometry. If I minimize, I have a tiny sphere here. I added some keyframes like an arc shape just to have something moving in the scene so I can kind of demonstrate it to you guys. I called it Attract Repulse Influence. I can just add underscore geo as well on at the end, so I'm more clear about what I'm doing. And middle mouse, drag and drop it into the scene. Make myself a little bit of room here. Bring the object, go from out to in geometry. Make sure to plug that to the geometry, not to the influence. And all of a sudden, you have a case where the smoke attracts to this sphere right here, which is pretty cool. Let's look at the options really quick before we get too excited. Again, with the influence, you can just mask a region or use it in conjunction with simulate NPM. You have geometry where it allows the smoke to move towards the geometry or the opposite where it tries to repel. Then in the general, we have enable, disable. We have a geo shape where it's set to mesh, just a bounding box that you can create inside Bifröst, or bounding sphere that again you can create inside Bifröst. But if you have a customized mesh, I suggest you use mesh. Now next one is resolution mode, which is set to automatic, and that's the mode I'm going to use. You can use, let's say, relative, and that changes the way that this gets calculated. Basically, the detail size, geo detail size that you see here is specified relative to the bounding box of the input geometry that you have. Whereas with absolute, it's specified in word space unit. Again, You're not going to see much of a difference in a simple example like that. I'm just going to set it to automatic. Now, geodetail size specifies how well this operation takes place. Basically, it enhances the density of the voxel within that region where the smoke follows the object. So you can reduce this number to get a much better result. And of course, we have solid and shell. Basically, if your source is a closed object, then it's best to use solid. If it's an open object or basically not watertight, then it's best to use shell. And then we get to this rollout where you have attraction. Now, very similar to some other nodes that we covered, you can go positive and negative. A positive value will attract towards the geometry, and that's probably what we want to do in this scene, and a negative value will repel. Simple as that. And of course, the drop off here is the attenuation that we talked about. You can just create a fall off, or you can completely shut off the attenuation, so it will have an impact on the entire scene, and drag will apply. And of course, we already talked about drag as well. So what I'm going to do in this particular example, I'm just going to intensify the attraction so we get a much better result. And I'm going to increase the max distance with drop off on. Another alternative is to completely turn off these two. So that is going to be similar, but based on the scene scale that I have, I know that a value of 20 with drop off is going to work just fine. So let's minimize and do a quick play blast. Now you can see how the smoke follows the sphere. This is really cool, and it can be extremely useful if you have that in your reference. Now, this is it. We covered important influence nodes within Bifröst. Of course, there's a lot to cover, but I think that would be appropriate for one video. I will create more how-to videos to add layers to what you already know inside Bifröst. But for now, I hope you found this video useful. You can access this scene on my Patreon website. Follow along here. You can follow me on Twitter as well. I try to kind of update everyone about all the latest releases, so on and so forth. So hope to see you there. I put some of these useful links like introduction to Bifröst Aero or how to create fire with Bifröst Aero in the description. So make sure to check that out too. Thank you very much for watching, guys. Until the next video, see you guys soon.